Naming covalent molecules is a lot more straightforward than naming ionic ones. Covalent molecules are going to follow a molecular formula instead of an empirical formula. Remember that covalent bonding is going to have, let's say I've got two hydrogens here. These hydrogens are going to be sharing their two electrons. So each one owns one and shares the other with the other hydrogen. So covalent bonding is going to have these single bonds, one at a time. And because of that, we can make basically however many bonds we need. So I could have carbon attached to another carbon, attached to a hydrogen, all over the place like this. I could throw an oxygen on here attached to another hydrogen. And because of this, I could just have a chain like this. I could have these completely unique molecules, right? So I could have some proportion. I could have some proportion of C to O to H here, but that doesn't really tell me what's going on in this picture. I would need to physically count 1, 2 carbons, so I'd have a C2, and then 1, 2, 3, 4 oxygens, so O4, and then 1, 2, 3, 4, 5, 6 hydrogens. C2O4, 6 would give me the molecular formula for this structure, for this covalent compound. Okay? So when we have covalent compounds, they are going to have a completely unique molecular formula. And so we want to be able to go from a formula to a name. So let's put a few examples up here. Let's go from a formula to a name. Let's start with something like N2O4. This is going to be nitrogen, this is oxygen. So we're going to take these two as our base elements. So I'm going to put a nitrogen here, nitrogen, and then my oxygen here. Okay? Now, the first thing, the second word always gets its end shifted. Just like in ionic bonding, instead of oxygen, I'm going to get oxide. We're always going to end in an ide. The second thing is I'm going to give a little prefix here. So each of these is going to get a prefix that tells me how many times that's occurring in my molecular compound. So here, nitrogen, there's 2 of them. Well, 2 goes with the prefix di. This is dinitrogen, and then oxygen, there's 4 of them. It goes with the prefix tetra. This is dinitrogen, tetraoxide. How about something like C2H6? Those would be dicarbon, and then 6 hydrogens, that would be hexahydride. So pretty straightforward, right? Now there's one other rule that we need to consider, and this is the mono rule. If I've got CO2, because carbon's coming first, I'm just going to write carbon. This only happens to the first element listed. This still gets dioxide. So carbon dioxide means I've got 1 carbon, 2 oxygens. But if I have CO, carbon, and 1 oxygen, then it's still carbon. I'm going to drop the mono from my first word, but it's going to be monoxide. I'm still going to include the mono on my second element. So this isn't carbon oxide, it's carbon monoxide. It's a weird little thing that we do in chemistry. I'm not sure why. So let's look at a few more. Let's just go, how about P8S? This would be octaphosphorus. And then 1 sulfur is going to be monosulfide. Okay? And how about S3Cl5? This would be trisulfur. Then 5 chlorines, that would be pentachloride. So that should be pretty straightforward. So in covalent bonding, we're going to be using the molecular formula. And that contrasts with ionic bonding, where we're going to use the empirical formula, where we're going to be focused on the ratio between those elements. Where in covalent, we are focused on the exact number of that atom that's in that compound.